Now let's move on to the next presentation. May I call paper ID 13 to kindly come forward and present your work.
Plugin இருக்குன்னு ஒரு அமௌண்ட் இருக்கு சார் இருக்கு டாக்குமெண்ட் அது
So, good afternoon to one and all present here. So, my research paper name is a hybrid deep learning framework for sentiment analysis. So, it combines that bidirectional LSTM, CNN, and attention mechanisms for social media data.
What's your affiliation? Where are you from?
I'm from Dr. Elijah Education Institute, and I'm studying in second year. Arrhat Nag.
First you have to tell your name, the author, the second name, right? Your name and your supervisor name should be there, and the organization name and affiliation should be there.
13.
You create some document background. Document background.
So, we formerly know the platform Twitter, now currently known as X. So, over 500 million tweets are generated daily, and there is a problem known as noise. Like in tweets, many of the users' tweets are like LOL, laugh out louder, or be right back. And there is a linguistic complexity too, such as negation. Let's say in Amazon review, you have seen, right? They are adding 5 stars, and on the header they are adding not good at all, and the second review they are doing, it's very good. So like it's a negation, right? So our goal is to develop a model that is accurate like but fast enough for real life development. So this is a solution hybrid architecture. First, it uses bidirectional LSTM. It captures sequential context like the past and future words in a tweet, and then it uses the CNN. It extracts the local features, n-grams or phrases. And it has an attention layer which assigns weights to important words, filtering and out noise. So our model is based So a model is based on eight stage pre-processing pipeline. First, URL mention and removal. So we'll use the regex method to eliminate the HTTPS of the URL or any username is there, and then levinization is there. So let's say there are words such as beta and it will change to good, and running it will change to run. And there's a slang expansion like LOL, as I said you, it can be extended to laugh out louder. And then there's special character normalization as well as contraction expansion. Like if they're saying don't, it will change to do not. And as well as elongation normalization, like many of the tweets are there, they say good, it's very bad, BAD. So it will reduce it and make it the appropriate character. And then there is tokenization as well as hashtag reprocessing. So it will remove the hashtag. So as you can see that the URL mentioned removal, it accounts for 2.3% accuracy in our model. So likewise for the linearization and slang expansion appropriately. So this is a diagram of a 8-stage pre-processing pipeline of social media text. So here in model configurations, we use concatenation of word to vector and TF-IDF keyword importance. And for the bidirectional LSTM layer, we use 128 units and 10H activation. And for CNN layer, we use 256 filters and kernel size was 3. As well as dropout was 0.5 to prevent overfitting. And then optimizer was Adam. And then the dataset we used is Sentiment 140, which is available in the Kaggle dataset. Next page. So this is the experimental results. The model left base got around 81.5% accuracy and F1 score was 81.1%. However, our proposed model hybrid was around 94.2% in accuracy as well as 94.1% in F1 score. As you can see, there are many other models too, such as the support vector machine as well as random forest, CNN, LSTM, bidirectional LSTM. So it has their own accuracy and F1 score. So as you can see here, the evaluation study, so full model has around 94.2% accuracy, and if we do it without attention, so it will have around 90.5% accuracy and 3.7% change. As well as you can see that without CNN, without bidirectional LSTM, and word to vector, then TF-IDF, no pre-processing, then pre-processing stages 1 to 4 and 1 to 7. Next. As you can see that in the no pre-processing one, there is a big change of 10.3%. So you can see that the pre-processing is very important in our model. So here, our proposed model, our parameters was 47.3 million, and the BERT had 110 million, which is 3 times smaller. And then, as you can see, through GPU2, we have latency of 450 per second, whereas the BERT model had 110 per second. So our model was faster than 4.1 times. As well as training time was 4.5 times faster too, and it was even cheaper 4 times. And you can see that the heat map, as you can see that, like you can say in the Amazon there are fake reviews and all. So first it will start with negative or any positive, and in the header, and the next in the comment section they will write, okay, it is very good or it is very bad. So it's a negation. So as you can see that the negation gives the highest attention weight of 0.55 here. So an example I gave you, not good at all and very happy with the product. So it's a combine. And this is the conclusion. It achieved around 94.2% accuracy on Sentiment 140 dataset, and it has robust pre-processing pipeline, improved results by over 10%. And it has much more superior handling of negation and sarcasm compared to baselines. And our future work will be supporting the non-English tweets. And thank you. I'm Arrhat Nag, and my supervisor was Gayatri, assistant professor, and we are from Data Science Department, Dr. MG and Educational Research Institute. Thank you. Any questions?
There will be mixed tweets, right?
Mixed tweets, yes sir.
Good, better, ability, worse, risk. That gets how to do the analysis.
Okay.
No, how the system will come to a conclusion that it's good or bad.
Yes, sir, I'll explain you. So here, pre-processing examples. So we can see here example 1. and the same raw tweet. Easy as it is. At the John, oh my god, this movie is so good, best movie ever. So the pre-processing, what it will do first, it will remove the URL.
First the tweet says that it's a good movie.
It's a good movie.
Come to the second one.
Second one, after the changing of everything, it will show, oh my god, this is a movie, this is good, best movie ever. Then again, for the emoji, there's love.
Okay.
And there's another sarcasm too. For the negation, I told you, oh great, another Monday morning. We don't even know that what user says, whether it's a good way or a bad way.
So you got three responses.
One is positive, one is negative, one is negation, combined of both.
What's the conclusion?
Conclusion is that, let it down. Like here, detailed analysis. First, it will see the adjectives. So adjectives will have the highest amount of weight, 0.45. Like it has example of amazing, terrible, and then the negation words. The second most important, like not, never, no. So here you can see that adjective receives 9 times more attention than function words. Likewise, there are for verbs, nouns, and function words too. So it will calculate the whole total score, and then it will give the whole value, whether it's a, let's say 93% positive or maybe 1% positive or completely 100% negative and all.
You are assigning weights to each term and you're
Yes, sir.
having that.
Yes, sir.
Okay, what about the stop word removal?
What about that?
Some punctuations are there, right?
Yes, sir.
The exclamation marks, that should be removed, right?
Yes, sir.
How do you do this?
Like the here. Here you can see the hashtag. It comes in the hashtag split too, like the best movie ever. So the hashtag will be removed, but in the punctuation mark, like exclamation mark, it will same work as the adjective one. So it will have the highest attention weight, 0.45. Because if we put exclamation mark in the sentence, it emphasizes the words like, oh my god. Let we say explanation work. That it means oh my god has an important weightage.
Given 2 or 3 consecutive also, how many words weightage you are taking?
Each words will have weightage. So each word will have, a sentence will have adjectives, then verbs, nouns, as well as the function words that is a, and then it will have negation too if it's a negative sentence, like it is not good, it never happens, like that. So each words will have this average weight, and then it will calculate the total number of it.
What about the other languages?
Other languages are not implemented as of right now. That is a limitation in this model. Only English tweets.
Only English.
Yes, ma'am. And this is a training curve of the dataset. We stopped at around epoch 20 because after epoch 20 it is overfitting here. So we, at 20 itself we found around 93.8%, which is the best accuracy we could find. And this is a table. And this is a dataset we used, Sentiment 140. It had 1.6 million datasets. It had 800,000 positive and 800,000 negative, where we used 70% for the train, 15% for the valuation, and 15% for the test split. And then for cross testing, we used the IMDb reviews, around 50,000 reviews, and we used the COVID-19 tweets too. And we found out that average twin length was around 14.7 words. And this is a limitation of errors. So our main challenge with the model is the sarcasm. So it is around 34% errors in sarcasm. Like, oh wonderful, my flight is cancelled again. So I can say, oh wonderful, it's a positive. Again, my flight is cancelled again. It's a negative too. It's a combination of positive and both negative. It's used as sarcasm. So it will have highest amount of error. And
These are your drawbacks.
But that should
Drawbacks.
That should be minimized, right?
that should be minimized. Yes, sir. Yeah, like the current model, the literature review, which I have studied, is that they have around 40 to 70%.
It makes the model confused, right?
Yeah. Yes, sir.
Okay. So you should try to minimize the error percentage of error, right?
Yes, sir.
But it's still higher.
it's still higher. The kind of literature review, it's around, which I have seen mostly, it's around either 40 to 60%. So compared to that, it's much more less error. Thank you.
Thank you for your questions and valuable feedback. I thank the presenter for the excellent presentation